Okay, today we're going to be doing simplifying rational expressions. And so what we need to talk about what a rational expression is basically any number that can be written as a fraction. So like 7 is 7 over 1, which is a rational number. A rational expression would be something like x minus 9 over x plus 7. Okay, so the first thing we need to talk about is domain. We need to review that. And the fact that any rational number cannot have a 0 in the denominator because we cannot divide by 0. So you can have anything in the numerator, and the denominator cannot equal 0. So in order to figure out what it can't be, we just set it equal to 0. So if we have x plus 2 over x minus 3, I want the denominator, so x minus 3 equals 0. So x equals 3. So the domain would be x such that x cannot equal 3. Now I want you to start using set notation because we're going to be doing a lot with intervals, and I want set notation used on domain. And also make sure you label it because there's lots of other things, and I need to make sure what I'm looking at. So we do need to remember that any polynomial, x squared plus 5x minus 6, that domain would be all real numbers. So we would say x such that x is a set of all real numbers. And a square root or any even root, so the number here would be even, cannot be negative. And that's the radicand. That's what's underneath, can't be negative. So the first non-negative number we have is 0. So we would set whatever is there to 0. So the square root of 2x plus 4, I need the domain there. And so I set 2x plus 4 equal to 0. So I subtract x and divide by 2. So I have x is negative 2. So I have to make a choice now if it's going to be all numbers greater than negative 2 or all numbers less than negative 2 that will work. So I plug it right into the radicand there. Oops, I lost you there. I plug it right up in the radicand. So a number greater than negative 2 is 0. Is greater than negative 2. And then number less than negative 2, let's go negative 4. So if I plug negative 4 into here, I get negative 8 plus 4, which is a negative number. All I care about is it's negative. When I plug 0 in here, I get 0 plus 4, which is positive. So it's going to be numbers greater than negative 2. So my domain is going to be x such that x is greater than equal to negative 2. Now the fun thing about this, so we had all three different, so we have rational, polynomial, radical. Now the fun thing we can do with this is we can set them and we can combine the two. So let's say, well again it's a polynomial, there's no restrictions, so my domain is just x such that x is the set of all real numbers. Well, that wasn't too bad, right? Okay, and then what about 1 minus x over x? Again, I don't care what my numerator is. I can have 0 in my numerator all day. It's my denominator. Well, my denominator can't be 0, so it's just x such that x cannot equal 0 because I cannot divide by 0. And then the square root of x plus 7. So again, set it equal to 0. So x negative 7. So am I going to be greater than negative 7 or less than negative 7. So greater than negative 7 is negative 5, less than would be negative 9. So plug in negative 9 minus 7 is a negative. Don't want a negative. Plug in negative 5 plus 7 is a positive. So I want, again, I want these greater than numbers. So my domain is going to be x such that x is greater than or equal to negative 5. And I think I'm off the screen again. And there you go. That's, rewrite that so it's nicer. X such that x is greater than or equal to negative 5. Okay, but what if I combine these two together? What if I combine them? So I have, let's see, x minus 6 over the square root of 2 minus x. So here's another example. Just made it up. So I don't care what the numerator is again, but the denominator can't be 0, and it can't be a negative in the square root. So I have two conditions there. So I still set the 2 minus x equal to 0. So I have x equals 2 because I added over the x. So I need to figure out if the numbers are going to be bigger than or less than. So less than 2 is negative 2. Bigger than 2 is negative, not negative 4, positive 4. So I plug in 4. Oh, negative 2. So I get 2 plus a negative 2. Well, that's 4. That's a positive 4. So if I have 2 minus 4, well, that's a negative. So I don't want the negative. I'm going to want the less than this time. So my domain is going to be x such that x is less than 2. But you notice I didn't put the equal to because at equal I'd have a 0 and I can't divide by 0. So just a refresher on domain. Before we start, because I want you finding the domain on everything we do. So simplifying I need to remind you that I have AC over FC. This is multiplication, so I can reduce the C's out. They become 1, and A times 1 is A, and F times 1 is an A, and F times 1 is F. But what if I give you x plus 6 over 3? Can I reduce that? Well, my answer is no. You can't reduce that. You can't reduce that because this appears a quantity. A division bar is actually a grouping symbol, just like brackets or parentheses. So we can't add, so we can't divide. So the answer to this is just x plus 6 over 3. Many times I will get x plus 2 as an answer for this because people will just reduce the 3's. You can't do that. I can separate it and I can have x over 3 plus 6 over 3, which would be x over 3 plus 2. But x over 3 plus 2 is not the same as x plus 2. So make sure, unless you can reduce out the whole quantity, you're not reducing. So how we do these things is we just factor first. We factor and then reduce the whole quantity. So I have x squared plus 4x minus 12 over 3x minus 6. So I need to factor both the numerator and denominator. So 1 is here, so 1 times 12 is 12. Factors of 12 that have a difference, because right here, of 4. So I have x minus 2 and x plus 6. And on the denominator, I can factor out a 3, so I have 3 and x minus 2. Now, I did tell you that I wanted you to do domain, so I want you to do that before you reduce, and how I do it is set everything equal to 0. So 0 can't equal 3, there's no variable, but here x equals 2, so my domain is going to be x such that x cannot equal 2. It's my domain. Now I'm going to go back and finish simplifying. I have an x minus 2 here and an x minus 2 here, and I'm left with a 3. Don't forget about that 3. So I have x plus 6 over 3, which is funny. It came out to be what the top one was. So let's do another one. I have 4x plus 12 over x squared minus 3x minus 18. So again, the first thing I do is factor. So I can factor a 4 out of the numerator. And the denominator I factors of 18 that have a difference of 3, so that would be 6, x minus 6, and x plus 3. I'm going to find my domain, setting both of these equal to 0. So I have the domain as x such that x cannot equal negative 3 and 6 from there. And now I can reduce plus x plus 3, the x plus 3, because the whole thing reduces out, and I'm left with 4 over x minus 6. So you're going to factor a lot. You're going to factor a lot and find the domain a lot. Some things you guys struggle with, so it'll be great practice. So I have 12 plus x minus x squared over 2x squared minus 9x plus 4. So the first thing you probably want to do is reorder that numerator because we don't like how it looks. So I have negative x squared plus x plus 12. And then the other thing that we did in class today, because my recording won't save, is I factored out this negative. So I now have negative and then x squared minus x minus 12 over 2x squared minus 9x plus 4. So now I need the factors of 12 that have a difference of 1. So I have x minus 4 and x plus 3. Don't forget that negative right there, so it has to come back. And then down the bottom, I have to take 2 times 4, which is 8. I need the factors of 8 that add to 9. So factors of 2x, so x and x. In order to get 8, I need to have 2 times 4, so there's a 4, and that's the factor, and 1, and they're both negative. So I'm ready to simplify, but I do have to do my domain. So x such that x cannot equal, setting these both equal to 0 again. So I have 2x minus 1 equals 0, and x minus 4 equals 0. So x is 4 here, and then I add 1 divided by 2, so x equals 1/2 here. So x cannot equal 1/2, or 4. Now coming back over, I can reduce. I have this and this whole quantity I can reduce. Now remember, don't forget about that negative there. So I have negative x plus 3 over 2x minus 1. Okay, so last thing we're going to do is multiply today. And when I multiply fractions, if I have 7/8 times 10/9, I can reduce up and down or diagonally. So 9 and 7 don't reduce, but 2 goes in both 8 and 4. So 2 goes in 8 4 times and 10 5 times. So now I can take 7 times 5 and 4 times 9 and get 35/36 rather than getting 70 seconds and having to reduce. I did my reducing before, so it can help me out. And what that does is when I get rational functions, such as 2x squared plus x minus 6 over x squared plus 4x minus 5 times x cubed minus 3x squared plus 2x over 4x squared minus 6x. I do not want to take this quantity times this quantity divided by this quantity times this quantity and then reduce. I want to reduce first. So before I can reduce, I have to factor. So 2 times 6 is 12, so negative 12. Factors of negative 12 that have a difference of 1, so I have positive 4, negative 3. So just factoring, so 2x and x. To get 4, that has to be 2. And that has to be 3, so negative 3 plus. And then I have to do the bottom, so factors of 5 that have a difference of 4, or 5 and 1. Okay, now this right here, I'm going to factor an x out before I even start. So I have x times x squared minus 3x plus 2. So now I have the factors of 2 that add to 3. So I have x from out here, and then x minus 2 and x minus 1 all over. I'm going to factor out a 2x here. So 2x, and I have 2x minus 3. Now, again, up and down are diagonally, so nothing up and down here. Oh, how about here? I can reduce this x and this x, so that's nice. And then diagonally, I have an x minus 1 and an x minus 1. And then I have a 2x minus 3 and a 2x minus 3. So I'm left with x plus 2. Guys, x plus 2 times x minus 2 over x plus 5. Forgot my 2. I'm going to put my 2 in front of here. Now I can multiply out this numerator because I know they're conjugates, but you can also leave them there. So since they're conjugates, I square the first and subtract the square of the second. Remember that middle term would zero out, but you don't have to. I think it's nice to leave it right here so you know. Now in this case, for my domain, I would have to look at these factors and these factors, all of them. So this would be, I would have negative 5 here. I'd have 1 here. I'd have 0 from that x. And then I'd have 3 halves here. So I would have a domain that had quite a few restrictions. So x such that x cannot equal negative 5, 0, 1, and 3 halves.